Alright, so in this video, we'll be looking at organic chemistry for grade 12. So the question is saying, use the displayed structure shown to answer questions that follow. So when you look at this structure, the first thing for you to understand or to identify the structure, you have to look at what we call the group or the homologous group or the functional group, I can say. So you look at the functional group, then you are able to tell which compound is being drawn. So from here, we know to say that we have O with a double bond, C, single bond, or H. So when you have two oxygens arranged in this way, meaning to say this is an acid. Okay, it is an acid. And this group here, we call it as carboxylic group. Carboxylic group. So acids, they have a functional group called a carboxylic or carboxyl group or carboxylic group. Then in terms of naming the organic compound, just very simple. We use the suffix, let me say, what's this? The suffix, which is meth, eth, prop, but, pent, ex, ept. We also have oct, nano, and deca. So those ones are representing the position of the number of the position represent the number of carbon. Like for example, meth, it has 1 carbon, eth, it has 2 carbons, prop, it has 3 carbons, but, it has 4 carbons, all those things. So according to this structure, we have how many carbons? We have 2 carbons, meaning to say this is eth. Since it is an acid, so it is going to be called as ethanoic acid. As simple as that, isn't it? So the question is saying, name the organic compound shown. So I've already given you the answer. Let me just write it here to say this is going to be an ethanoic acid because it has 2 carbons. When it has 3 carbons, it's going to be propanoic acid. 4 carbons, butanoic acid. So this is ethanoic acid. So how do you tell? Because of this functional group here, a carboxyl group. So this is the carboxyl group. Carboxyl group. The second one is saying, to which homologous series does it belong? So ethanol belongs to the homologous series of carboxylic acid. So these are carboxylic acid. Carboxylic acid. So also have alkanes, they belong to the homologous series of alkanos. Let me say not alkanos but alkanes. Then when it comes to alcohols, this is an acid, but when it comes to alcohols, they belong to the homologous series of alkanos. So I have to take note of that also. Then this one is saying ethanol, which is different from ethanoic acid. So ethanol is an organic compound which belongs to homologous series known as alcohols. So draw a displayed structure formula of ethanol. So you have to understand the formula for the let me say the molecular formula for alcohols. So this one is given by CN H2N plus 1 then OH. So this means to say this OH is the functional group. So the functional group, you put it at the end. So since this one is ethanol and it has 2 carbons, so C is equal to 2. So what are we going to do? If I put 2 here, then I put 2 here, this one is going to be 4. 4 plus 1, that is 5. So it's going to be like this, but it is saying draw a displayed structure formula of ethanol. So how is it going to look like? We have 2 carbons there, so I have to write them as this. And then we have 5 carbons. So 1, 2, 3, 4, 5. And this one is going to be the functional group. So you write it like this. Okay. And this is going to be our final answer for ethanol. So this is ethanol. And this is supposed to draw a displayed structure. Alright. Then this one is saying what term is used to describe the manufacture of ethanol from ethene. So what usually happens here is this. We have an ethene, which is an alkene. For us to produce an alcohol, we have to add water to an alkene. So this is an alkene. This is L. Let me just do this. Okay. This is an alkene. Then we add it to water. Then here we are going to produce what? An alcohol. So this is the formula. But what the question is saying here is this. So we have ethene, then we are adding water. Then here we are producing ethanol. Okay? We are producing ethanol. Now what process is this one? Whenever you are adding water to something, that is hydration. Okay? Hydration reaction. So in terms of the answer to this question, you can just say this is called the hydration reaction, because we are adding water to an alkene. Hydration reaction. Question C. Butyl propanoate is an ester. So esters, they can be artificial or they can exist as natural, like the way flowers, they smell. Some of the flowers, they smell good because of the esters. They occur naturally, as well as you can make them. So the question is saying, name 2 reagents used to form it. So remember, here we have butyl propanoate. For an ester to be formed, you have to react an alcohol plus an acid. Then you're going to form an ester. Then an ester is formed. So ester is formed from the process of esterification. So esterification, during the process of esterification, an ester is going to be produced plus water is also going to be formed. So that is one thing that you have to understand here. Now in terms of the naming of an ester here, you need to be very careful when giving the reagents here. When naming an ester, the first thing that we consider is an alcohol. So this word here, you are able to read it as butyl propanoate, meaning to say this is an alcohol and this is going to be an acid. Let me repeat. When you're naming an ester, you need to start with an alcohol. Okay? Then end with an acid. That's the format, isn't it? So meaning to say we have butyl propanoate. So this is going to be an alcohol. Okay? And this is propanoate, meaning to say this is going to be an acid. So the reagents which are going to be used to form butyl propanoate, the first one is going to be butanol. Okay, butanol. Then in terms of propanoate, this one is going to be propanoic acid, isn't it? Because butanol is for the alcohol, propanoate is going to be propanoic acid. Propanoic acid. So these are the 2 reagents. Don't swap them whereby you say butanoic acid and then propanol. They are going to mark you wrong. Then describe a chemical test for the minor byproduct of esterification. So like I said, esterification produces what? It produces water. It also produces an ester. So in terms of the minor, what's this? The minor byproduct of ester, the chemical test, you find that when an hydrous copper 2 sulfate is added in water, what is going to be the change? The change is going to change from, the change that is going to be seen there is from white to blue. That's a test of water, isn't it? White to blue. That's a test of water. So the test of water, you add anhydrous copper 2 sulfate. Anhydrous copper 2 sulfate. When anhydrous copper 2 sulfate is added to water, water changes from white or colorless to blue. That's a test. Then let's see question D, Roman numeral number 1. It is saying state 2 uses of ester. So ester has a lot of uses in terms of making perfumes. It is also used in flavoring food, drinks, and so on. So it has a lot of uses. You can even include more. Roman numeral number 2 is saying give one similarity between esterification and neutralization. So you know to say that under neutralization, salt is produced and water, okay, and H2O. Under esterification, an ester is produced. We also have water being produced. So we can just say both esterification and neutralization, they produce water. That's a similarity. So thank you very much for watching, and remember to subscribe and share the video to your friends.